Welcome back to our final video this week for radicals, where we have rationalizing. So we just learned about multiplying by conjugates, which will get rid of radicals in the denominator. The whole point of that was for back before we had button calculators. Dividing by a radical was an ugly mess. Dividing into a radical was easier to do, and you could stop when you had the number of decimals you wanted. The other way around, you were like, I don't know, it's kind of this. All right. So the square root of 6 over the square root of 10. So our math grammar rules for simplified, correct answers are we need to move, not move, but we need to do something so we no longer see a square root in the bottom. So that's square root of 10. I need to multiply it by something that when the two multiply, there's no longer a radical. So I have a 10 under the square root. What do I need? So I have a pair of the same thing. Hopefully you guys are seeing, I need another square root of 10. So what I want to do is multiply the bottom by the square root of 10. So I'm going to write that. But this was not an equation. So multiplying the bottom would be the same as dividing by. So I don't have another side to also divide by the square root of 10. I just have an expression. So because I don't have another side, I have to do this a little differently. So what we can do when we have expressions is we can add weird looking forms of 0, or we can multiply by weird looking forms of 1. So I'm multiplying here. So I need to know, what does 1 look like if the denominator is the square root of 10? So what divided by the square root of 10 would be 1? The square root of 10. So hopefully you listened to that and learned a little more about why this works, why we can do it, because we're multiplying by a weird form of 1. When you're doing unit conversions, you are multiplying by a weird form of 1. Like 1 foot is 12 inches. Those are equalities, so we can use them as a unit conversion fraction in either order. And it is a weird form of 1. All your stuff in chemistry is multiplying by really, really weird forms of 1. 6.02 times 10 to the 23rd molecules in 1 mole. Molecules, moles, those are set to be equal, so you can multiply by it because it's a crazy form of 1. All right. So now we're going to do the multiplication. So on the top, I have the square root of 6 times the square root of 10. I can crunch those numbers. Square root of 60. And the bottom is now just the number 10. Cool. So I can figure out what the square root of 60 is, some ugly decimal, and then divide that by 10, which moves a decimal. We really like that. But the square root of 60, that's a pretty big number. I need to know if that has a pair or not, because it may have one. So let's take that to the side. So we got it from 6 times 10. May as well use the pair we got. 6 is 2 and 3. 10 is 2 and 5. So there is indeed a pair of 2's. And left over 3 and 5. So now I'm going to change the square root of 60 out for 2 times the square root of the leftovers. 3 times 5 is 15 over 10. Now I have things outside the radical. Those can interact. So the 60 and the 10 could not divide together. This doesn't poof become the square root of 6. Because the 10 is not in a radical anymore, the 60 is. Now you might notice here, if I'd merged them together, I could reduce the square root of 6 over the square root of 10. They're both even. So it can go back into one fraction, reduce it, then pull it back out and go. I deliberately picked these so we would see having to reduce the top. So the 2 and the 10 reduce, and what we end up with is the square root of 15 over 5. When you type this, be sure that the over 5 doesn't end up inside the radical, because then you went to all the effort of doing it right and you typed it in wrong, and sometimes Alex's error messages aren't as nice as we would like. So just be on the lookout. So, but that is our rationalized answer. I can calculate the square root of 15 as the square root of 3 times the square root of 5, and then divide that by 5 and get however many decimals I want from it. All right, we're just going to continue to do more of the same. So these first 4 here, there is only one thing in the denominator. I'm going to scroll. E and F is going to have more than one thing, 2 things in the denominator. That is where we will make use of the conjugate. So for now, it's just more practice. Sorry. So this square root of x 40ths is really the square root of x over the square root of 40. Now we can go one of 2 ways here. So the square root of 40, that's 4 times 10. I know 4 square roots. I could simplify this radical now and then just worry about rationalizing the radical and leaving the part that comes out alone. Or I can just get rid of it and then reduce that result. I usually tend towards the second because sometimes you don't notice that the first one reduces. So that is what I'm going to do. So I no longer want to see the square root of 40. So I need to multiply by what I have. So they have the same thing under the square root. Likewise up here. So we now have the square root of 40x over 40. So we have done as requested and no longer have a radical in the bottom, but we have to actually figure out what square root of 40x reduces to. So the x is going to stay, but that 40 has the 4 times 10. Pair of 2's, left over 2 times 5. So this is equal to 2 square root of 10x over 40, and that 2 divides into the 40, and we get the square root of 10x over 40. I'm sorry, over 20. Reduce. All right. Now, sometimes when I write, I'll put this little hangy thing at the end. That is to say the square root extends over the x, but does not go past that. So just if you see that in my handwriting, that's all that means. All right, let's see if I can move these down because that looks crowded to me. Indeed. Wow. All right. Now C can be a little trippy. It looks like there's 2 terms on the bottom, and there is 2 terms inside the radical, but there is only one radical. And it is the radical we want to get rid of. So we are going to multiply by that radical the same way we just multiplied by the square root of 40 and the square root of 10. All right, so that is what we're multiplying by. So on the bottom, square root of a thing times square root of a thing is just the thing itself. So on the top, I have the 4 onto the crazy radical. And on the bottom, it is just the thing. And some people would certainly argue that does not look much prettier, but the radical got moved. Now, there are some times where we have a radical on top, and we use this process to move the radical to the bottom. Usually only shows up in really weird calculus problems. So that's all she wrote. So this 4 cannot interact with that minus 2. X minus 2, I put it in parentheses. You don't have to write or type the parentheses, but I like to see it because it reminds me that is a thing together. I can't reduce unless I get a whole X minus 2. All right. Now D, 3 over the square root of 3. I actually picked this deliberately. This shows up a lot in pre-cal. So if you took pre-cal, you might be like, that is vaguely familiar. So again, we want to move the square root of 3 from the bottom, or get rid of the square root on the bottom, I should say. It looks like it's moving because it's like it was on the bottom and now it's on the top. It's not technically moving though. I can't just pick these up and move them around. I just multiply by a creative 1. So the top is now 3 square roots of 3. And the bottom, square root of 3 times square root of 3, is just 3. Aha. So look at that. 3 divided by the square root of 3 is the same as the square root of 3. Square root of 3, I can look up straight in the table. 3 divided by the square root of 3 is a horrible, ugly mess to do by hand. So this is why we rationalize. But if I needed the reciprocal of the square root of 3, 1 over the square root of 3, I'd have to rationalize it, and I would actually get to square root of 3 over 3. So if you were wondering like where all the random different answers came from, a lot of them were relating by rationalizing a flipped fraction. Now, the real meat here. E. That is a horrible, ugly mess. But if I multiply by something, a crazy form of 1, I can no longer have fractions on the bottom. So now it is not multiplying by exactly what we have. If I square that, it is not going to get rid of all the radicals. Get rid of some of them. So it is going to look similar. I'm going to drop parentheses there because this is now a binomial. So what I need to multiply by is a binomial. I know I need to see a square root of 13 to multiply to the square root of 13. I know I need to see a square root of 10 to multiply to the square root of 10, but I need to make use of that difference of squares here so the outside-inside terms cancel. So instead of a minus sign between them, I will put a plus sign between them. So when I multiply these two things on the bottom, it's the difference of squares. Inside and the outside terms cancel out, and it's just going to be the square root of 13 times the square root of 13 minus the square root of 10 times the square root of 10. 13 minus 10, 3. So it goes from ugly mess on the bottom to an integer. But I'm not done. Like that was what's going to show up on the bottom, but I have to multiply by a crazy form of 1. So if I want to do this on the bottom, I must do the same on top. Now on top, a lot of times, honestly, we don't want to actually multiply the top out. Leave it like that. If the top has more than one term especially, just leave it. All they're asking is to rationalize. Once there are no longer square roots in the bottom, done. Because a lot of times what happens is after you finish multiplying the bottom, you get some reduction. But you only see that nicely if you leave it factored. So don't multiply. So we're going to leave the top like this for the time being. Now the bottom. Now again, like we saw in the previous video with multiplying the difference of squares, the outside inside terms cancel out. So this on the bottom is going to be 13 minus 10, like I talked through earlier, which is just 3. And that 9 and that 3 interact nicely. So we have 3 multiplied to the quantity square root of 13 plus square root of 10. You could distribute the 3, but honestly, just leave it like that. It's fine. Alex will take it. If it doesn't, email me and I'll go fix it. Probably with a hammer, but still it's a fix. All right, last one, we're going to rationalize again. We happen to have a variable, so that means we're not going to get this lovely number minus number equals another number. So the bottom won't be super pretty, but it is going to move the radical. And that is the whole point here, is we have problems where we have to do algebra with a mess like this. And This is what we would do to move the radical around if that's what we wanted. Like that's what we decided to do. So it's not a right or wrong, what's the right thing to do here. This is just a thing we can do. So the 4, I don't actually need the 4 to get bigger, but I have to put something to go with that square root of x term. And the only way a difference of squares work is if it's the same a plus b, a minus b. So the only way I will get my cancellation is if that is 4 plus the square root of x. If I just multiply by the square root of x, it'll get rid of the second one, but it'll put the square root on the first one. All right. So again, like I said, on top, don't interact those. Leave it with the parentheses. Don't do more work than you need to do, because all it amounts to is more typing. And then the bottom, 4 times 4, 16. The outside, 4 square roots of x, and the inside, minus 4 square roots of x, cancel. And then we have minus square root of x times square root of x is x. And again, I'm going to sneak those parentheses in on the bottom. The 2 cannot interact with the 16 because that is not just 16, it is 16 minus x. I don't know if x is even, odd, decimal, big, small. Can't interact those. That is the rationalized, simplified answer. I know it's not really simple, but it is the result. So in calculus, this is usually we have to add or subtract it with another crazy fraction. So this is part of that ridiculous process. All right. So that is all of our rationalization. Don't forget, Thursday, test review. Be there or be square.